So we're still on this SNS topic, and let's maybe pick it up from here. I was trying to make a point there the last day. I did complete it, but I just want to reinforce it. So the point is, okay, we have our publisher here for our SNS topic, and the publisher can be anything, or well, it can be many things. It doesn't have to be a Lambda in the lab, as you know. The S3 service is actually the publisher. But either way, there is some event source that's publishing messages. Well, let's not call it an event source. Sorry. There's some resource that's publishing messages into an SNS topic. Now, unlike SQS, SNS straight away passes that message on to its subscribers. Yeah. Um, and as we know, the subscribers can be a number of types of resources, including Lambda. But it's this idea that once SNS receives a message from the publisher, it immediately tries to send that message on to the subscribing services. So it's a push rather than a pull. In that with SQS, as you might remember, it operated in a pull format in that the receiving service polled SQS for messages. That's not the case with SNS, so it's a completely different integration model. And I talked about integration models way back. If you go way back to the early days when we started to look at Lambda, I said Lambda had what was it, three integration models: synchronous, asynchronous, and poll-based. Well, we've actually seen all three now. Synchronous, an example of the synchronous was when API Gateway was sending events to our Lambda. Poll-based was when SQS was integrated with Lambda. And here we are now with the asynchronous integration model, where SNS is integrated with, for example, a Lambda. Uh, so that's fine. And the other thing, I guess, is that clearly, maybe not, SNS, if the subscriber is a Lambda function, SNS does not communicate directly with the Lambda function. It communicates with the Lambda service. If SQS, in a similar kind of way, if an SQS queue was the subscriber, then SNS would be communicating with the SQS service. But if we go back to the Lambda service, so what SNS does is it tries to send the message on to the Lambda service. And hopefully the Lambda service acknowledges the receipt of that message. And at that stage, SNS is out of the equation. It has done its part. SNS does not wait for a response from the Lambda function itself, which kind of leads to the issue of, well, if the Lambda function throws an exception, who or what deals with that? This is always the case, like when we've got asynchronous communication or poll-based communication. What if the message processing piece of code actually throws an exception? The exception never finds its way back to, your client, whether that be a web app or a mobile app or whatever. But there has to be some way of uh, recording exceptions being thrown and identifying the message that caused the exception to be thrown, and processing that faulty message. Yeah. And we have that with SQS. That's where the DLQ, dead letter Q, came into play with SQS. It's kind of similar with SNS, as we'll see. So that's fine. Let's move on. Um, Now, I didn't demonstrate it, but we had the simple scenario of, let's supposing we've got uh, the CLI as our publisher, an SNS topic, and a Lambda as the subscriber. And I'm showing you here, look in the code excerpt, how we'd set up that in the CDK. And it's all pretty straightforward. This is how you add a subscriber to a topic. And because there are different types of subscribers, you have to specify what type of subscriber you are subscribing, and then the actual instance of that subscriber. In our case, it's a Lambda function. And here's our topic. And once I think from this stack, what we just output is the topic ARN. And you can use the AWS CLI then to send a message to any topic once you have the topic's ARN. And we'll see doing that in a while, but it's just a CLI command. All we're kind of vaguely interested in is what does the Lambda receive, yeah, or how does it receive the message? And as with all Lambda functions, it has to be contained within the event object itself, the event parameter object that it receives. So that's what I'm showing you here, right? This is a screenshot from CloudWatch logs, and I'm showing you the event object of our Lambda subscriber. Now, if you remember with SQS, SQS sent batches of messages to our Lambda. And the way we dug out the batch was we had a records property within the event object. Well, it's the same with SNS. We've got this records property within the event object again. And you can see from the syntax, it's an array. And here's just one message in that array. So that kind of suggests to us that SNS sends batch of batch of messages to our lambdas, and that's kind of what I'm kind of stating up here, right? A Lambda subscriber receives a batch of messages, right? But I have a question mark, and we can confirm that when we look at the actual detail of the event object. We have this records property, and it's an array. And we know from looking at the documentation that it's inside in this records property. That's where you will find the SNS message in your Lambda. And because it's an array, well, that suggests it must be a batch. But the truth of it is that, in fact, SNS doesn't batch messages at all. Every message that SNS receives from a publisher, it sends that message individually to the subscribers. It doesn't do any batching, right? So, like, there's a contradiction between what we're looking at here in the screenshot and what actually happens. Now, I don't know why. I don't know why the event object, because the event object is created by the Lambda service. Okay, so it's the Lambda service creates this event object because it's the Lambda service that actually invokes your Lambda function. So the Lambda service creates this event object. It adds this records property, and it makes the records property an array. Okay, but still, it will never, ever, ever receive a batch of messages from SNS. So I guess it's probably some kind of legacy issue or whatever. So, there's a slight contradiction, I guess is what I'm trying to get across. There's a slight contradiction between when you look at the code and when you read the documentation about SNS. And just for the heck of it, what I actually did was like any good person does today, I asked AI this question here, right? Does AWS SNS batch messages for Lambda subscribers? And here's the answer I got back, and begins with no, it does not. And the rest, okay, you can freeze this screenshot later on if you want to, or ask AI yourself this question, and you'll get the answer back that no, it doesn't do any batching. So, as I said, there's a slight contradiction when you look at the actual event object and what the reality is. So that means inside our Lambda function, we don't really need a for loop to iterate over this array because the array will never have more than one entry in it. So we can just index directly into subscript 0 of this records array. We don't need a for loop. Can't remember whether I put a for loop in my code or not, but you don't actually need it. Right. And oh yeah, that's how we actually invoke, or that's how we talk to SNS from the CLI. Now I haven't shown you the JSON object, this JSON object that I'm sending in my message, but if we looked at the detail here, we can see that it's just a simple object with name, address, email, I think, something like that. And again, the message is serialized. So SNS, just like SQS, serializes messages. So you have to parse them within your Lambda code. So we know that in general, you can have multiple subscribers to the same topic. Now, a fairly common pattern that we use with SNS and lambdas is this, well, sorry, not just SNS and lambdas, but with SNS in general, is this fan out pattern. And this is just one example of the fan out pattern. So here we've got an SNS topic and we've got three SQS queues that are subscribing to that topic. And presumably each SQSQ has a Lambda consumer. So we would have a Lambda here for each queue. And so that means whenever a message is published into my SNS topic, SNS will push that message to each of these queue subscribers. And the Lambdas over here on the right then, the Lambda service will poll this queue, and if we get back a batch of messages, um, there may be a batch or maybe just one because SNS might send a number of messages into the queue before the Lambda service polls it. So either way, the Lambda service will poll the SQS queue, receives back a batch of messages, and it passes those on to our Lambda. And the Lambda service does the same for this queue and the Lambda on its right, and the same for this one. So we have three lambdas here. These are three separate lambdas now. They're not the same lambda running inside in three micro VMs. Yeah, they're separate lambdas. And so the idea is, I guess, is that these lambdas are processing in parallel each of the messages that are being sent to this SNS topic. So that in general, that's called the fan out pattern. The fan out pattern is more general than the specific example, because maybe we might have two queues as subscribers, and we might have even a lambda. We could have a lambda here as a direct subscriber, and we might have another subscriber that is SES, the simple email service. That would be another example of the fan out pattern. So it's one that we see that you would see quite a lot in messaging based or event driven applications. As an example of this fan out pattern, supposing we have an SNS topic, and again, just for convenience, we're going to use the CLI as our publisher. And this SNS topic has two subscribers. One of them is a Lambda that's directly subscribed, and the other subscriber is an SQSQ. And that SQSQ, it also has a Lambda consumer. Yeah, so let's supposing that's our little mini architecture. And I'm showing you down here. Well, let's look at it in VS Code, maybe. So here's our topic, and we're not configuring it much so far, so there's not really any significant configuration of the topic in this example. But there are obviously a number of configuration settings, but most of them we don't really need to know about. Here's our queue, or SQSQ. And then we've got some lambdas. So based on the name, anyway, this is lambda is going to be uh, this lambda is going to be the subscriber, the lambda that's directly subscribed to the SNS topic. That's okay. This lambda, again, just based on the name, this lambda is the consumer to our SQSQ. But they're just ordinary lambdas in one sense. Here is where we're subscribing. What are we subscribing? We're subscribing the lambda to our topic. Here we're subscribing the queue to our topic. Again, there are some configuration settings. Am I doing anything? I'm setting that. All right. I'll come back to this later on, but either way, anyway, there are two subscribers, and we also need to connect up the queue consumer, which is what we're doing here. We had that last week, and that's our full stack. And I'm outputting the ARN of the topic because I need that. The lambdas themselves don't do anything useful, they just do console log the event. That's really all I'm interested in so far anyway. There's some extra little stuff going on here, but we're not interested in that now. And similarly for the lambda that's consuming messages from the queue, all it does is a console log. This other lambda here, we're not using at all at the moment. So I have deployed this. Actually, one thing we might look at just before we start sending messages is if we go to the Lambda service, Lambda. And let's see, this is the queue consumer. I just want to check the permissions on it. So you remember the execution policy, the last day or from a while back, the execution role associated with a Lambda determines what services that Lambda can talk to. So this is we're looking at the queue consumer, and here's its execution role. So I just want to see what policies are attached to it. And there are two policies. This policy here is just the default policy that's associated with every Lambda. It's the policy that allows it to send messages, do CloudWatch logs, send logs to CloudWatch. Yeah. This policy, if we actually go into it, it's the policy that allows, you see here, it allows my Lambda to essentially talk to SQS, right? So I have a Lambda that has permission to talk to SQS, and I can tell you that it's this Lambda here, but it's not talking to SQS. All it does is a console log. So why has the CDK and CloudFormation given this Lambda permissions to talk to SQS? Well, if we go back to the stack, those permissions or that policy has been attached to that Lambda because the Lambda. I mean, I could have shown you this actually a while back when we were talking about SQS, but because I've set up this link here between that Lambda and the SQS queue, and what I've highlighted here now is what makes my Lambda a consumer of the SQS queue. Even though the Lambda itself does not talk directly to SQS, it must still have permissions that allow it potentially to talk to SQS, because otherwise the Lambda service, we know that the Lambda, for SQS, we know the Lambda service does the polling on behalf of the Lambda function. But the Lambda service will only do that polling if the Lambda function has the necessary permissions. So if you like, the permissions that are attached to the Lambda function, that is what allows the Lambda service to do the polling of the SQS service. And I just showed you there in the management console that my Lambda, that's the Lambda that is the queue consumer, it does have the necessary SQS permissions, which will allow the Lambda service to do the polling on its behalf. Yeah. And let's look at the other one. The other Lambda is the one that's directly subscribed to SNS. A little bit confusing, all this stuff, but so if we just close off that, and here's the oh, sorry, I'm in the wrong Lambda. I need to go into the other Lambda. So if I go back to here, but I'm in the wrong service. Yeah, I need to go back to. So again, we're currently looking at the Lambda that's subscribed to, sorry, the Lambda that's consumer of SQS. I want to look at the other Lambda though, the one that's directly subscribed to SNS. Which is it this one? Yeah, it's this one here. And if we look at its execution role, there may be nothing in it now. I'm not certain actually how it works with subscribers. But my hunch is that it won't have anything. No. So this one actually only has one policy, but that's the default one. So it looks like in the case of SNS subscriber or Lambda SNS subscriber, the way that AWS allows the Lambda function to receive messages from SNS is not by means of the Lambda execution role. It actually does it on it does it possibly on the, although if we look at triggers, sorry, now I'm slightly, we have triggers here. Oh, sorry, let's back to Lambda, sorry. No, we don't have triggers. Oh, there are triggers on the left. And here's how actually in the management console we can find the link between the Lambda and the SNS. So It's not a policy as such. It's not an IAM policy. It's slightly different. Okay, that was a slight diversion. So, just to finish off the point, we're being told here now that a trigger for this lambda, what lambda? This lambda here. A trigger for this lambda is SNS. And that has been configured because in my CDK code, I have this subscription here, this subscription, right? I probably, if I looked at SQS, I could find a link between, because this is essentially creating a connection between SNS and SQS. So we won't do it now, but we would find somewhere within the management console the effect of this piece of CDK code. Right. Anyway, let's send a message to my SNS topic. So let's remind ourselves again. This is my architecture. So I'm going to send a message to the SNS topic, and I should eventually find an execution of this lambda, by means of a log stream, and I should see a log stream for this lambda as well. And when we look at the two log streams, we look at the event object, and hopefully we'll find the actual JSON structure that was published by my CLI in the first place. Yeah, that's the plan. So the message that I'm going to send is our standard, this guy here. Yeah, simple JSON structure, name, address, email. And I think I did it beforehand. So that's our command, AWS SNS publish, the topic ARN, and minus message, sorry, minus attributes. You can ignore this part of the command, right? The minus attributes. We'll come back to that in the next lecture. But it's this part here. It's what we're interested in. Minus message, and then a reference to the file containing my message. I could have left out this attributes part entirely. It doesn't have any impact at all in this case. So if I hit return and Q out of that, and I'll go over the CloudWatch logs. You kind of know the drill now at this stage. I go into CloudWatch. Some of these are legacies, I'd say, but let's see. That's a legacy. Okay, these are the two that we're interested in. This is the log stream for the Lambda that's a direct subscriber, and this is the log stream of the Lambda that's a consumer of the queue. And so if we go into this one first, this is the Lambda that's a direct subscriber, into the stream, look at the console log of the event. Here's our records property, but as I was saying at the beginning of the lecture, it's an array, okay, but it's never going to have more than one object in it. So this is the entire, if you like, this is the message that SNS passed on to my Lambda. And, there's an SNS property here. And if we drill down into the message property within the SNS object, that's where our actual JSON object is, again, in serialized form. So we need to parse that. So that's fine. And if we look at the log stream of the other Lambda, the one that's a consumer of the queue, So if we go back to here, and that's this log group. Sorry, it's this log group here. And this is the log stream. So now we're looking at a Lambda that is a queue consumer, right? And the messages that are going to be delivered from the queue to this Lambda were messages that were first of all sent to SNS. Let me just bring it up, maybe. Okay. My CLI sent a message to SNS. SNS sent the message on to SQS. SQS, by means of polling, sent the message on to my Lambda, which means that the message that the Lambda received is an SQS message that is a wrapper for an SNS message. So there's kind of two uh, wrappings or envelopes around our original message. And so if we look at the actual log stream, and if we look at the console log of the event, here's our records property again. So here's our array. This now is an SQS message. And the body of the message is the SNS message. And buried inside in that, if we look at, it's always hard to find. Yeah, over here, right? There's a message property. This is a serialized JSON structure, obviously, but one of the properties in the serialized object is a property called message, and the value is the actual JSON structure. Okay, so we always, that's why I have a console log at the beginning of every Lambda. Every Lambda that we've ever looked at has a console log of the event at the start of it. And the reason I do that, obviously, is so that we can see what is the actual structure, because what is the structure of the event object, because it's different depending on what is the event source. The event source in the example we're looking at right now is SQS. The event source for the other Lambda that I was looking at a moment ago was SNS. But there's a slight additional complication in the one that we're looking at right now, because, okay, we're looking at the event object where the event source is SQS, but the messages that were put into SQS came from SNS. So that's why it's slightly, that's why the body is, got so much in it. Okay. Like anything, you got to play around with these things to. So what I'm showing you here is a screenshot of the event object for the Lambda subscriber. This is a screenshot for the Lambda that is the queue consumer. So we've got this thing called the SNS envelope, right? And so where this comes into play is when SNS is when SNS sorry when SQS is a subscriber to an SNS topic, SNS wraps the message that it wants to send down to SQS. It wraps it in an envelope, and we kind of saw that. If I go back again to here, um, my actual message begins. Where was it again? Gosh, where is it? Oh yeah, my actual message kind of begins here, right? But what's all this other stuff about? And that's the what we're calling the envelope. And there's part of the envelope is down here as well. So this envelope is added, is wrapped around the message that SNS sends to SQS. The more you say these things, I think the more confusing it gets. But anyway, we have to live with it. So we've got this envelope that SNS kind of wraps around the message before it sends it on to SQS. Now, there can be useful information in that envelope, but often we don't need it, right? And so one of the things you can do when you're in your CDK, at the CDK level anyway, is you can disable this envelope inclusion. And that's what I'm showing you here, right? So if we do that, now, if like just for now, if you take a mental shot of what I'm just showing you here, take a mental shot of the body of this message. Sorry, we can see there's a lot of stuff in it. And if I now go back to my CDK code and I disable the inclusion of an envelope by setting this property to true, essentially kind of we're saying we just want the raw message. I guess that's where it gets its name from. We just want the raw message sent from SNS onto SQS. We don't want SNS to wrap the message in an envelope. So I've changed that to true. I need to do a CDK deploy. And I'll send my exact same message, and you'll see that the body is going to be much slimmer than what I'm just showing you, what I'm showing you here. While that's deploying, I'll go back to here. They're deploying. I can actually show you in the slides. SNS envelope. Let's see. Here's again here's the message that was received by my SQSQ when the envelope is included. So my body has got quite a lot in it. Yeah, this is the envelope beginning here and ending down here. This is the actual message itself buried inside in it. So the envelope is included there, but if I disable the inclusion of the envelope, this is what my message looks like. And you can see the body now just has the message itself. It doesn't have that extra metadata at all. Okay, that's essentially the effect of the configuration change that I made there. So just to be sure, if I send the same message again, takes a while now because there's a queue involved and there's polling involved. It can take a little while before the message actually finds its way through. So if I go into the logs group, which one is it? This one. Here's my new log stream. And if we expand this, there you can see my body now is much slimmer, just has the message itself. Okay, that's this idea of the SNS envelope. Now, the question that arises, if we go back to here, or a question that arises is, if we go back to here, right? So you can have a Lambda that's a direct subscriber to an SNS topic, Or you can have a Lambda that's linked to a queue, and the queue is the subscriber to the SNS topic. And the question is, well, which of these two approaches should you use? Should you subscribe your Lambda directly, or should you link the Lambda to a queue and make the queue the subscriber? Are there advantages to this approach over this approach, and vice versa? And that's what I'm documenting in this slide here. So it's kind of the question is it Lambda versus SQS to Lambda? Which subscriber option should you use? This option or this option? And I'm saying here that this is the disadvantage of having a Lambda as a direct subscriber are these, right? You don't have any batching. And I've talked about that at the beginning. So that means for every message that's sent to an SNS topic, SNS will kick off, will eventually cause the creation of a micro VM to execute our Lambda function. For every single message, there is a micro VM instance created. That was not the case with SQS. I showed you that, right? SQS will send a batch of messages to a Lambda instance. So you don't have any batching when you've got a Lambda direct subscriber. You've no control over Lambda concurrency. And I showed you that we could control concurrency when SQS was involved. The Lambda function, the Lambda function itself is actually going to be responsible for handling any errors. So if my Lambda subscriber, my Lambda that's a direct subscriber to an SNS topic, if for whatever reason while it's processing a message, it throws an exception, how do we deal with that? And we have to deal with it. Well, that's probably slightly badly worded here. It's actually dealt with by the Lambda service. But we need to configure our Lambda function to tell the Lambda service, here's what you should do if my Lambda function throws an exception. We'll see that probably the next day, maybe. Might get to it today. So there are all the disadvantages of having a Lambda as a direct subscriber. The only advantage to having a Lambda function as a direct subscriber is this one here, but it's not insignificant, right? If the processing that's being done by the Lambda function is time critical, as in you want the execution to happen as soon as possible after the message has been kind of generated, then you should make the Lambda a direct subscriber. So if I go back again, a couple of slides. So here's our Lambda, it's a direct subscriber. Whatever the source of the message was, okay, it's our case, it's a CLI, but it's usually a Lambda function really. Whatever the source of the message was, once that message gets to SNS we know straight away passes it on to Lambda, and the Lambda is going to execute and process the message straight away. Whereas when you've got a Lambda over here that's processing the message, then there's going to be a delay because of the polling that's involved between here and here. And so if there's a delay, then, and we want the message to be processed as quickly as possible, it's time critical, then using this architecture is not a good idea. You should subscribe the Lambda directly to the SNS topic. For all the other cases, I guess you would say this is the approach you should use. If you want to control Lambda concurrency, if you want to have batching, all of that, right, then use this setup rather than this setup. Yeah, so that kind of answers that question because it's an obvious question, right? Should you subscribe a Lambda directly or should you go via a queue? How are we on time? We're okay, actually. I'm just going to finish off on this one. It's about delivery policies, delivery protocols and policies. Sorry now for reading it, but so it says SNS defines a delivery policy for each delivery protocol. By each delivery protocol, we really mean by for each type of subscriber. So SNS has a predefined delivery policy for each type of subscriber. And the delivery policy kind of controls how SNS should handle um, situations where it is unable to deliver a message to a subscriber. That's essentially the main point of these delivery policies, which is what I'm saying here, right? The policy defines how SNS retries the delivery of a message. When server-side errors occur. So let's see, reading it now isn't great, but when the delivery policy is okay. Maybe if I go on to the next slide. This is taken directly out of the SNS online documentation. And so what it's telling us here is it's documenting these delivery policies that SNS follows. And the way you just interpret this simple table, probably sure you work it out, is here are the different types of subscribers. Now, the only ones we're interested in are when it's a Lambda subscriber or when it's an SQS subscriber, right? These are other subscribers as well, which we're not interested in. And there are some subscribers down here that we're not interested in. So whether it's a Lambda subscriber or an SQS subscriber, this is the delivery policy that SNS follows. And you'll actually see it's pretty damn exhaustive, right? So first of all, it will retry 3 times without any delay if it's unable to deliver a message. So our SNS now is trying to deliver a message to either the Lambda service or the SQS service. But for whatever reason, these two services are not acknowledging receipt of the message. You know, the service may be temporarily down, there may be a networking issue, whatever. The subscribing service is not acknowledging receipt of the message. And so SNS has 3 goes at trying to deliver the message without any delay between the 3 attempts. If it still is unable to deliver the message, it moves on to this part of the policy. So it's actually going to try 2 more times with 1 second delay between each attempt. If it still can't deliver the message, it moves on to this part of the policy. It has 10 more attempts at trying to deliver the message. And it now introduces delays between each attempt in the sequence, and it follows what's called an exponential backoff algorithm. Really, all that means is that, you know, it tries to deliver the message, then it delays for a second, then it tries again. If the second try fails, it doubles the delay period, which means we're now up to a 2-second delay. So it waits 2 seconds, tries to deliver. If it fails again to deliver the message, it doubles the delay period. So we're now up to 4 seconds and keeps on going until it has 10 more attempts at trying to deliver. It still doesn't give up. It now tries this number of times, believe it or not, over, what does it say? This number of times with 30 seconds between each attempt. And eventually it gives up. And I think what it says over here is that it keeps on trying for, 24, 23 days. So the upshot of it anyway is that, you know, it doesn't give up easily in trying to deliver the message. And this is kind of, this is kind of built into the SNS service itself. And, you know, it's built into it because of the asynchronous nature of the communication between our SNS and the actual ultimate subscriber, whether that be a Lambda function or an SQSQ. Because everything, because communication is happening over a network, then, there are going to be times when there are network failures. So this is how SNS deals with potential uh, unavailability of a subscribing service. Just keeps on trying for over 20, what is it, 23 or 24 days. So that's what we mean by SNS's delivery policy for each type of protocol. Protocol here really means a type of subscriber. Yeah. And you can see, it's the same policy that it uses for Lambda, SQS, also Kinesis is another service that we haven't looked at. In the case of SMS and SES, sorry, SMTP, is SES in there? I don't see SES in there, but in the case of some other services, then it has a slightly different policy that it follows, which you can read yourself. But this is the only one that we're actually kind of interested in. So it's pretty good in terms of, I guess the idea is that it tries to guarantee as much as it can delivery of every message to the actual subscriber. Right. That's where I think I'll call it a day for today. And we still have a little bit more to do on SNS. In fact, we probably got about maybe 4 more lectures or thereabouts to get through. So, but that will be after Easter. Right. I guess that's it for today. I'll see at some stage tomorrow during the interviews for the assignment. So unless there are any questions, I can terminate the meeting. No. Right, that's it. Talk to you later.